Hello.
Yay!
Hello. I'm Taylor. I'm co-founder of Space, Paul. Let's get into it. So today I want to talk about session backends. So session backends are an architectural pattern that we've been seeing a lot over the last several years. So I'm going to talk a little bit about those first, and then I'm going to do a demo, and then obviously going to do a demo of something that he's put together that also uses session backends. So first, let's just remind ourselves how a typical web application architecture works. So you're on a website, you make a request that hits a service, that hits maybe another service, and at some point you hit a database. So one of the key characteristics here is that you have stateless services sitting between the database and the browser, which is great. It makes it easy to scale this architecture. So if you have a bunch of users show up to your website, you just add more nodes that can deal with the extra traffic, and any request can be routed to any of these nodes because the servers are all stateless, and it just makes it easy to scale, which is great until you want to have some highly interactive feature on your web application. So typically what happens here is we try to pull some state down from the database and stick it in browser memory. And that enables things like cross-filter. So cross-filter is a project that was released by Square like a decade ago at this point. And in this example, it's loading in 230 rows of flight data into browser memory, and then it creates this sort of interactive exploration. So this is a project that I did several years ago. It's called City Byte Commute. This is also loading in a lot of data into the browser, and it's giving you this sort of 3D WebGL view that lets you interactively explore the data set. So this is about 60,000 rows of City Byte data. And so this interactivity is made possible just because we're pulling so much state down into the browser. But there are limitations to this approach. So you might have too much data to load into browser memory, or maybe it's too much data to push over the public internet, or it's too expensive to push this data out of your data center. You might need specialized hardware. So if you are building a video editor in the browser or an AI-powered creative tool in the browser, you might need some specialized hardware.
You might also have multiple clients who you connect to edit the same state. So this might be like a Figma-style application. You need a source of truth somewhere that can be quickly updated, and then all the connected clients can get back the latest state. So these limitations are things that Session Backends could possibly address. So let's describe Session Backends this way. We'll start again with the browser. And this time we're just going to give it its own dedicated backend that's just for the user session. And because it's just for that user session, it can be stateful. So we can pull state from the database, and we can stick it in the session backend to be used just for that user session. And then the user's browser application can connect directly to it using WebSockets. So in this way, you can kind of think of these two together as a client application. So where most traditional web applications, the client application lives entirely in the browser because that's where all the users' local updates are happening there in the browser. There's no state, right? There's no, all the servers between the database and the browser are all stateless. In this case, because we have a stateful server, this together sort of becomes the client application. So you can think of it like an Electron app, where you have like a thread for the UI, and you have a thread for the node process that's running. In this case, the node process, or whatever process it is running in a backend stateful session. So the difference here is that it's just like having a local process, except this one runs in the cloud. It can access more data. It can have access to specialized hardware. And it can easily share state among several connected clients. So this means like every user that comes to this application gets their own stateful backend, or in some cases you might have several users who connect to the same session backend if they're editing the same state, or if they're playing like the same game. So I want to sort of illustrate the session backend use case with with this application called Real Developer. So Real Developer is an open source tool for exploring data sets with SQL. It's open source. You can pull it down, install it locally. What it does is it starts up a local server that spins up a DuckDB instance. DuckDB is a in-memory OLAP database that's really for highly interactive analytical workflows. And then the web application part of it connects with WebSockets to that DuckDB instance, and SQL commands are streamed forward and results are streamed back. This is built by the folks over at Real Data. Hamilton Ulmer is the engineer who's been leading this project with his team. And he's been sort of doing this style where he's building in public, and so he's got a lot of updates on his Twitter. So we'll shout out to Hamilton. You should follow him for updates on this tool. So let's do a quick demo. Let's see if this works. So just to give some context, what I've done is I've taken Real Developer and I packaged it up in a Docker image. So that's what I'm doing here. And then I'm going to take that Docker image, I'm going to push it to a platform that we built that's called JamSocket. JamSocket is it's a platform that we built that's really just meant to help engineers add session backends to their applications. And then lastly, we're going to spawn one of these session backends. So what this command is going to do is it's going to tell JamSocket to take that image that we pushed up and create a running container. And I passed in a URL here that points to a data set that I have stored in Google Storage, Google Storage bucket. So this is the same city-like data set that I was using for the previous visualization. Instead of 60,000 trips, this is loading in 5 million trips. And in about a second, you get back a URL, which takes you to the running application. So in this time, it's holding what's about 120 megabytes of data. It's stuck it in its DB instance, and then it's started up this application, and it's opened a WebSocket connection. So here you can see that you're able to type some SQL commands and interact and get back results. And then it's also streaming results for showing top level distributions of values in each column here inside. And as you change the query, you get a filtered table over here that also does the same sort of distribution of values for each column. So I think one of the things to point out here is that it's responding quickly, right? These are making requests to the cloud, right? This isn't running locally on my machine at all, and it gives you feedback right away, right? When you make a syntax error, it's telling you the syntax error. When you have a valid query, it gives you the result right away. So here I'm just looking at. It's probably hard to read this, but I'm trying to find the sort of start station and end station pair that's responsible for the most trips. And for those who are interested, the city bike stations are in Central Park. Turns out. And then the other cool thing about this is because this is a session backend, it's in the cloud. You can take this URL, load it in another tab, and you get the same state. So you sort of get this free multiplayer where you can share with others. And when you edit the queries, you can see the query changes for all the connected clients. So So I mentioned a little bit about JamSocket. JamSocket is this platform that we built that makes it easy to spawn session backends for your application. It's built on this library that we've open sourced called Spawner. So if you are interested in learning more about Spawner, come chat with one of us. And you can learn a bit more about JamSocket and Spawner by going to drifting in that space. And that's it.